So for redox, I have identified several difficult concepts that will be taught. So the first one is actually the four definitions of redox. So what I think is actually difficult is because it actually increases the cognitive load of the students, where they actually need to know the four definitions of redox, four for reduction and four for oxidation. Okay. The second difficult concept is the symbolic representation of electron transfer, where they are actually not able to see the electron transfer in the macroscopic sense. The third one is actually the calculation of oxidation states for more complicated ions or compounds, and they are actually more used to the calculation of oxidation states in simple ions or compounds. The next one is actually the identification of oxidized and reduced species for more complex reactions, where they are more used to having a two reactant and two product reaction. And last one is actually the test for oxidation and reducing agent observations, where the students actually need to state the colors that they actually observe, not only the final color, but also the initial color of the solution. Okay, moving on to some alternate conceptions that students would have is that first one, they will actually think that oxidation only occurs with oxygen, and they do not realize that oxidation can occur without oxygen present. The next one is that reduction must occur with hydrogen, and again they do not realize that reduction can also occur without hydrogen present. The next one is that they will assume that redox, because the name actually has the word ox inside, it only involves oxygen. Okay, and then the next one is we have the blind application of the oxidation state rules without actually considering the different permutations of the same compound. Next one, the most crucial alternate conception that we actually have is that there is a sign convention issue of the oxidation state versus the charges, where the oxidation states has the plus before the number, and the charge has the number first and then the sign. Okay, so for my instructional package, I actually scaffold it such that it actually reduces the cognitive load of the students. So first, they will actually be understanding the four definitions of the redox in terms of oxidation and reduction, as well as to actually consider using mnemonics to actually help them in their memorization. Okay, so we will actually go by very structured ways. So we'll actually do oxygen first, and then moving on to hydrogen, the loss and gain of oxygen and hydrogen, and then moving on to the electrons transfer and the oxidation states. Okay, then after they are done with the four definitions, we will move on to actually calculate the oxidation states, where they will apply the different rules to actually try and determine which is actually oxidized and which is actually reduced. And last one, we will actually scaffold it accordingly by introducing to them how we actually test for oxidizing and reducing agents, using the appropriate reagents for oxidizing agents and reducing agents. Okay, and also to imbue in them the need to actually state the initial and final color of the solutions when we have oxidizing agents and reducing agents. Okay, for my worksheets that I actually prepared, I actually start from a very simple calculation of oxidation states depending on the rules that they need to apply, and then moving on to more complex ones where they actually need to identify which is being oxidized and which is being reduced, and then determining which is then the oxidizing agent and which is the reducing agent, based on the concept that the oxidized species is actually the reducing agent, and the reduced species is actually the oxidizing agent.